So our first question, explain the meridional circulation of the atmosphere and its importance in the world climate. So mainly meridional circulation के बारे में बोलना है of atmosphere and mainly atmospheric meridional circulation and its importance in the world climate. First of all, our answer is the modern school emphasizes a three school models of meridional circulation, mainly Hadley cell, Ferrel cell and polar cell you can see. So now we discuss all the things simply. So mainly the model of meridional circulation of the atmosphere, where it is believed that there is cellular circulation of air at each meridian. So mainly cellular circulation of air at each meridian, mainly longitude area. Surface winds blow from high pressure area to low pressure region. We know all know high pressure to low pressure area wind blow and area. But in the upper atmosphere, the general circulation of the air circulation is opposite. In the upper atmosphere, it is mainly opposite direction of surface wind. So first of all, and thus each meridian has three cells. Each meridian has three cells. In the northern hemisphere, mainly tropical cell or Hadley cell, and polar cell, mainly polar front cell, mainly mid latitude cell, and or we can say Ferrel cell, and third is polar cell, mainly Hadley cell, Ferrel cell and polar cell you can see. And this diagram you can see 0 degree to 30 degree it is mainly Hadley cell, and 30 to 60 degree it is mainly Ferrel cell, and 3 mainly 60 degree to above 90 degree. There you can see polar cell. Okay, so you can see the winds blowing from 0 degree to northern area. You can see. So this symbol is the important, where in which direction when blowing. So it is mainly important. Please remember, and you can practice. And if you remember actually the direction of winds, then you can easily understand how to its move. So in the Hadley cell you can see. So mainly trade wind you can see, trade wind blowing from high pressure to low pressure area, mainly 0 degree area, mainly equatorial area you can see, mainly mid latitude area, mainly 30 degree area to 0 degree area, and 30 degree to 60 degree mainly westerlies. There you can see Ferrel cell. So wind blowing you can see the direction. So and 60 degree mainly again high pressure to low pressure area, mainly polar to subpolar area region. Wind blowing from polar region to subpolar region, mainly is 90 degree to 60 degree region. So it is mainly polar cell. So it is called actually tricellular meridional circulation. So first of all, a Hadley cell, G. Hadley identified this thermally induced cell in both this hemisphere in 1735. This time 1735. This time G. Hadley identified this. And surface winds is the name of trade winds blow from subtropical high pressure to subtropical high pressure region to equatorial low pressure, mainly 30 degree region actually subtropical high pressure. I also gave you wrong answer before. So it is mainly subtropical high pressure to equatorial low pressure belt in order to replace ascending air of the equator. And the upper air altitudes, mainly 30 degree to 35 degree latitudes, that to cause subtropical high pressure belt. Here you can see subtropical high pressure to subpolar low pressure belt. So wind blowing from subtropical high pressure belt to subpolar low pressure belt, mainly you can see Australis belt. So it is mainly actually called Ferrel cell or mid latitude cell. So mainly 30 degree to 35 degree latitudes to cause subtropical high pressure belt, and this anti-trade after descending near 30 degree to 35 degree latitude again, and blow towards the equator, and they are again heated and ascent and completed and it is mainly Hadley cell you can discuss, not it is Ferrel cell. So 30 degree to 0 degree region, this is mainly Hadley cell, and 30 to 60 degree it is mainly Ferrel cell. So mainly And this one complete meridional cell here you can see. Okay, similarly a complete polar cell is formed at the polar latitudes. However, according to new concept of circulation cellular model, circulation in mid latitudes are not completely explained. Hadley cell mainly here discussed. Hadley cells, polar front cells and subpolar cells helps in explaining the monsoonal mechanisms and frontogenesis and weather effectivity. So it is mainly Hadley cell or polar cell or Ferrel cell all describe what actually describe. It is mainly monsoonal mechanism or frontogenesis, how to frontogenesis occur, or weather effectivity in the polar regions. So it is mainly described here. So however, in all the pressure belts are not thermally induced, that is subtropical high pressure and subpolar low pressure belts. Thus, the concept of meridional circulation of the atmosphere does not explain the full weather effectivity. It does not explain the full weather effectivity across the globe. So, it is mainly one of the bad things. So, now we discuss all the things. So, it is mainly important, and this diagram is important. You can see in the symbol, and wind direction is important here. Please remember wind direction. So, thank you.